Okay, go ahead and copy down these graphs. I'll give you a little bit to do that, and then we'll talk about them real quick. And as I said, we've got quite a bit of stuff to look at here in 3-4. Just kind of depend on how much you remember from last year as to how this stuff should go real quick. And then we've got two other things we've got to look at that may take a little bit longer.
Like for today?
Yes.
Like, it's gonna take up so much time out of that.
We can count on it.
So we don't or we do?
Don't count on him.
Huh?
Don't count on the homework.
Don't count on not having homework.
Or are we gonna have to memorize all these?
Really, you have to memorize them. When I talk about one, you should
Suck it in.
have a good idea of what I'm talking about. And we've seen pretty much all of these already. Just kind of putting them all together here.
Just to ask. This weekend, me and Will were rabbit hunting with Clay. And we had this one rabbit. Will was on the other side of the road, and I was on this side of the road, because they run out of the ditches. And this one just kept running back and forth across the road. And we shot it like 2 times and it was still running. I'm like,
Another good shot.
I know. Well, have you ever shot at a rabbit?
Can't say that I have.
Are you kidding
You
me?
guys using?
A 22. Like a 20 gauge, yeah, we can hit it like first shot, but 20 gauge is something so fast.
Matt, you might need to borrow my 2 gauge. Good rap hunt.
I'm using 20 gauge. We're gonna have a rabbit fry. But it went in this little rock cubby.
Try to be country. They call it a rabbit fry.
That's what it's called.
You don't call it a rabbit fry.
It's a
What do you
rabbit
call it?
fry, Kenny.
You don't call it anything.
We're gonna have like 15 rabbits. It's gonna be a rabbit fry.
Fish fry. Fries. Fry up some frog legs or do fish fry.
You not fry rabbits.
No,
Well,
that's not
what would you call it then?
A rabbit.
What? You call it what?
That's
You just cook man?
all you use.
Fries,
It's not every day we have rabbits.
No. Come over to my house, they're everywhere.
They are. We found a good little patch. It's their nesting grounds or something, I swear. And then Mr. Asler, you know, like the big brush piles that they push up. Yeah. We get, they're huge, like 30 by 30. We get someone on top of those and you just jump around and the rabbits will just shoot out of there. We're gunning them down. Clay is like the worst shot ever. He had a 12 gauge and a rabbit ran across the open field. He shot 3 times and didn't hit it with a 12 gauge. Clears like this can, this old semi, will get you.
Please don't move that.
Yes, every time.
See what?
Every time you miss. We went 7.
Hey, Matt, where you
Okay.
guys at?
Real quick, let's kind of talk through these here. These are all parent functions.
Okay, good. I just wanna make sure I know where not to go.
These are all parent functions. What's a parent function mean?
Like
The daddies.
Okay, it's the most basic. Okay, it's the most basic. There's no moving of it. It's just the very basic. No other numbers involved other than just powers. Okay, or roots. It's the only numbers that are. Okay. And so what we're going to be looking at in this lesson in 3.4 is apparent functions, the shapes of them. And then in lesson 3.5, then we're going to start to move the graphs. Okay, we'll put in pluses and minuses and shift them up and down and left and right and stretch and shrink and all that good
It's
stuff.
this chapter.
Okay, so first parent function is a square root function. Notice that we are not negative. There's no negative x values on this graph because we can't have the square root of a negative number and be able to graph that. Cubed root, you can do the cubed root of a negative number. Absolute value, we've seen that before, that's always going to be a V shape. This constant is just y equals some number. I just put the b in there. Okay, but it's going to be y equals some number. Again, we've seen that. That's always a horizontal line. The identity is always y equals x. Okay, if we shift that at all, then it's not an identity. Okay, so that is one that has to be that specific equation. All of your x coordinates are the same as your y coordinates. So 1, 1, 2, 2, 2, 3, 4, 4. Likewise on the negatives. Cube function looks very similar to a cube root.
It's rotating.
Okay, just rotate it a little bit. Flip.
Grab a little.
Square function. Okay, quadratic function, another name for that. We looked at one a little bit there during questions. This one we haven't dealt with a whole lot yet. Reciprocal. But you can kind of see what that's going to look like. Again, those pretty quick explanation of those.
I'll see how they never go across the axis.
And how they only get closer and closer and closer.
Yeah, they have to at some point cross.
Okay, well let me give you an example. If I tell you to stand up in front of your desk,
Yeah.
and every minute that passes on the clock, you can go halfway towards the door. Okay? And the idea is, once you get through the door, you can go home for the day. Anybody want to do that?
No, and you'll never get to go home.
You'll never get through the door.
Have you ever done that to someone? I'm sure you did.
Okay? You know, halfway, yeah, it looks like we're making great progress. And then we go halfway and we get close. Man, this is great. I'm going to be going home. I'm going to be home for lunch. But you're only getting halfway. You're never going to get across that. Well, it's the same idea on that reciprocal function, that you're getting closer and closer to that x-axis, but you're never ever going to cross it.
Until you run out of numbers.
Until you run out of numbers. Thank you very much. Okay. The next function that we need to talk about. Last year you saw it as this.
Oh.
Anybody remember the name of that?
Yeah.
Give me a hint. So. Greatest concept. Greatest integer.
Greatest integer function.
Oh, good. You guys do remember it.
We such a good guess.
Okay, it's called the greatest integer function, otherwise known as what the graph looks like, which is a step function.
That's what I.
Okay.
Can we put the at the top and then it says TGIF?
What's that?
Can we put the above it so that says TGIF?
Sure, if you'd like to.
Oh, man.
see that on the calculator here in a little bit. Okay, and this is where we're gonna take a number and we're gonna round it down to the next integer. Okay, so for example, if we just have this basic y equals integer of x, and if I make a t-chart, and that's basically what we're gonna have to do on these, be able to see what it's gonna look like. And I'm gonna leave spaces in here on purpose. And if our x is an integer, okay, we're just plugging in, we're just trying to find the greatest integer, my y values are going to be exactly the same. When we start rounding is when we start getting into decimals or fractions. So for example, if have an x value of 1/2, okay, and we're always going to round down to the next integer. So if I'm at 0 on my number line, sorry, if I'm at 1/2 on my number line, and I'm going to round down to the next integer, that's going to make it
0.
0. If I'm at 3/4,
0.
0. If I'm at 0.9,
0.
if I'm at 0.9 repeating,
0.
still 0. Okay. What if I'm at 1/4?
0.
What if I'm at -1/2?
-1.
Negative.
Right, because I'm now here at -1/2, I'm still always rounding down. Okay.
Or if you're at negative.
If I'm at -0.2378,
Negative
go
1.
down to -1. So what that's going to look like on your graph,
The steps.
if I went and plotted all these points, I've got -1, -1, -1/2, -1, negative, 2.378, -1. Then at 0, 0, I hop up to here, and I'm up here for all these different points that we put in until I get to 1. If I did 1.5,
1.
still at 1. And so you can see we've got these steps. Now, we would have an open circle on the right side of all of those. Okay, because I'm going to stay at 0 until I get to actual 1, then it jumps up here. Stays at 1 until I get to 2, then it would jump up.
So you're counting 1, or you're not counting 1. Doesn't go.
Right, yeah, I am not counting this point, because when I do plug in 1, I get 1. Be a closed circle, yeah.
Because you are.
That's what I've got. I've got an actual point at 1, 1. Okay, let's change this a little bit here. Instead of x, we're going to go 2x. So let's start out with the same -1, 0, and 1. So now, anything that we have with an x, we're going to take times 2 first, then we're going to round down. So when I put in -1, what are we going to get? -2. And I 0. And when I plug in 1, now if I plug in a half,
So what is the one, so two?
when I take a half and put it in, I get 1, right? Is 1 an integer? Yeah. There is no rounding there. If I put in negative a half,
Negative 1.
negative 1. So I'm going to take 2 times the negative a half, which is negative 1, and negative 1 is an integer. Okay? So as I think about what I've got here, I've got negative 1, negative 2, negative a half, negative 1, 0, 0, 1 half, 1, 1, 2.
So you have to plug.
Do I have any steps?
No.
No, I don't have any points that are horizontal.
So you have to plug in.
So I gotta think about, let's do some more. Okay? If I plug in a 4th, what is 2 times the 4th? A half. Round that down to 0. Okay? What if I do negative a 4th?
Negative 0.5, round that down, negative 1.
Okay? Are we starting to see some steps?
Yeah.
Just
Yeah.
go for it.
What's that? What do we get if we do negative 3/4? Negative 2.
You go 3/4.
So, what we've got is to here, here.
Can we just plug these into our calculators? That'll work.
Yes. Let's look at that.
So we don't even need to do these graphs?
Well, you need to be able to understand, because sometimes, depending on what calculator you have, it may or may not give you what you're looking for.
I have the 84 silver edition.
Okay, so take out your calculator and go to the y equals. Okay, so if I wanted to plug this function in, okay, when you're in the y equals, you're going to go math, which is below the alpha key. You're going to arrow over on the top to number, and down to number 5, which is integer. And then we're going to do the same thing we have here, integer of 2x. And then we're going to graph that.
You got 5.
Now, how many of you have a graph like that? Doesn't look quite the same, does it? A window. Remember we had to change the window on that problem we went over? So go back to your home screen, so zoom, number 6.
What? Oh, that's awesome.
Now we can see the steps. Now if we want to get a really better idea, we would set the window to the same thing we've got, which would be negative 1 to 1, negative 2 to 2. Now, the TV, or the TV, the calculator will not show you the open circles.
We just have to.
So you gotta remember to put those in. Okay. Kinda remember that from last year?
Yeah.
A little bit. Okay. So that is greatest integer function. Okay. The next function is piecewise function. I know you did these last year.
We only have 6 more minutes.
I know.
No homework.
No.
Did you say no? You messing with us?
No, man, you don't mess.
If he goes, if he's messing with the best.
Equals. Live on 4 tracks. Live on 4 tracks. Live on 4 tracks. That's what you're. I already have it. Oh, you don't want? There's no plastic.
Okay, to graph piecewise functions. We graph each piece individually, then we'll look at the restrictions. Okay, so let's start out with our first piece. Y equals negative x plus 1. What's that going to graph as?
Down,
A line, a parabola, what?
a line,
A line because it's to the first. Remember slope-intercept form? What's our y-intercept?
1,
1, and slope is
-1.
negative 1. So if we think about that line with a y-intercept of 1 and the slope of negative 1, we're talking about this line right here. Okay, just hold, don't graph that quite yet.
And 2,
Okay.
x horizontal.
Now, whoa. We gotta finish the first piece. Because we also have a restriction.
Oh, yeah.
And that restriction says we're only gonna use that piece
From -1 to 1.
when my x is between -1 and +1. If it's outside of that, we don't care about it.
No good.
So therefore, I'm gonna erase everything when my x is bigger than 1 and when my x is less than 1, -1. Now, to be more specific,
Draw dots.
I'm gonna do a closed circle here
Not close.
and an open circle there. Why?
Because it has
And
greater than or equal to.
I'm also equal to -1, which is a closed circle, but I'm not equal to here, therefore it's an open circle.
And then on the next one, yeah.
What's that?
We go to 2,
Okay, y equals 2 is a
horizontal.
horizontal, that's a constant function, like what we went over at the beginning
But
of
it
the hour.
can go all the way negative,
Okay,
but it can't go all the way, it can only
so
go
we're
1.
talking about a horizontal line
Can't do that,
here too. Why not?
Because you only
because they can only go.
I only want it for this one specific point,
Yeah.
when my x is 1.
Boom.
Everything else, I don't want.
What's the wisdom marker?
X squared
X squared
is a parabola,
X squared is a parabola.
but we only want it greater than 1.
Okay, so hold on here. We're looking at a parabola,
A little baby one.
like this. Right?
But we only want it the left side of it.
Again, restriction, I only want when my x is greater your
The right side.
one. So all of this, when my x values are less than, I wanna get rid of open circle or closed circle.
Open.
Open, because I'm not including one. Open or closed?
Keep it the way it is.
Right, keep it as an arrow because we have no restriction for how big it gets.
Infinity.
That would be your final graph for that problem.
Then will it say what's the domain range?
Good. What would be my domain here?
Our domain would be 0 to all,
No,
0 to
negative,
negative 1 to
negative
1.
one always.
-1 to
Oh, I was
infinity.
thinking range.
Yeah,
I was thinking range.
Including -1?
Yes.
Yes,
Yes.
bracket.
And our
Range.
range will be 0 to infinity. Not including 1. Or not including 0.
Good.
Very good.
Any intercepts?
Yes. No.
One.
No.
Yes.
0, 0, 1.
Okay.
Okay, it goes to that point. This is not an intercept because we're not including that point.
Boom.
Let's just do our assignment so we can have our test Friday.
No.
Please.
I'll give you tomorrow to work on